Hi, I'm Celine, and today I'm going to be talking to you about a linear node class. And this is kind of a utility class that we use in data structures in order to allow us to build collections that are held together by links or references between different items. So let's get started. So the purpose of a linear node class is that a linear node serves as a container to store something that we want to store. So it contains a reference to the thing we want to store and also a reference to other nodes so that we can join these things together. And typically we're going to, with a linear node, we want to join things in a linear way, so forward and or backward. So the linear node itself is not actually a data structure. A linear node cannot hold an entire collection of whatever items we're interested in storing. It holds a reference to one. And so I like to think of a linear node as being like a Lego brick class. So with a linear node class, we can create a whole bunch of linear nodes, just the way with the Lego brick class, we could create a whole bunch of Lego bricks, and then these things can be put together. Now, how they are put together depends on the class that uses this. So the linear node class is going to be a utility that our other data structure classes are going to use. So let's take a look at what a linear node class is going to have. So we're going to implement it with generics because, of course, we want our linear node class to be able to handle any type of objects, whether that be student records or financial records or the shapes that we want to draw in a graphics program or turtle objects or anything. A linear node class will need a default constructor so we can just build an empty node. Typically, we'll also want to have a constructor that actually takes an element as a parameter so that we can build a node and right away as we create the node, put a reference to the object in it. And then getters and setters for that object or element. Getters and setters for linking this node to another node, typically the next node. And if we're going to create a doubly linked linear node, one that can allow a link structure that goes both backwards and forwards, then we might want a getter and setter for a previous node. So let's see what this looks like. Here's an overview picture of what a single link linear node looks like. So we're going to have a reference to it once we've created it because a linear node is a class, and so this is a linear node object, this whole thing here. And within this object, all we really have is two references. We're going to have a reference to another linear node. We're going to call this next. And so this might be null if we're not pointing to any other node, or it might be an arrow or a link pointing out to some other node. Because this is a linear node and it contains a reference to a linear node, we call this self-referential. Now, we're also going to have a reference to an object, a T object. So this is to stand in here for our generics. We're going to call this element. And again, this is not the object itself stored here. It's just a link to, a reference to that object. So this might be a reference to a turtle object if we're storing turtles in our nodes. It might be a reference to, a rectangle if we're storing shapes, etc. So that's the single link linear node. There is also a double link linear node, and in this case it looks pretty much the same except that we have this extra reference in here. So we've got next to refer to the next thing in the list, and we've got a previous to refer to the previous thing in the list. And of course we still have our reference to our element that is our generic object. So we probably have two different constructors. If we create a single link linear node using a default constructor, what we're going to end up with is this linear node object, and the next reference is going to be initialized to null, and the element is going to be initialized to null because we haven't passed in the object we want this linear node container to store. If we do pass in the object, then we're going to use a constructor that takes in the T element. And in this case, still our next is initially going to be null until we change that. But here our element actually, instead of being null, contains a reference to whatever this object is. So the point of having a linear node class is so that we can use them together. And so here's a picture of what it might look like if you had 3 single link linear nodes linked together. So we might have a reference that we're storing that gets us to the first linear node. And so maybe we call this first, and all this is, of course, is a reference, gets us to this node. The node is pointing to an object, but the next reference is actually pointing to the next linear node. And so again, here we have another linear node. The element points to the object, and our next points to another linear node. And here we have the final linear node in this linked structure, and we've got an object for that's being pointed to from element, but the next reference here is actually null because this is the last thing and it's not linked to anything else. Here is an example of what a double link linear node structure might look like if you had 3 double link linear nodes. Again, we have our first reference that gets us into the first linear node in our structure, and we are linking along, and then the last one has null for the next element. But note here we also might have a last reference that refers to the node that's at the end of this linear structure of nodes. And here the previous references are pointing back. So this one points back to this one, this previous reference points back to this one, and the previous reference for the node that's at the beginning of our structure here is null because there's nothing before it. Okay, so to summarize, linear nodes can either be singly or doubly linked, so they're either going to have 1 or 2 self-references in them. And they're always going to contain a reference to an element, which is how the linear node acts as a container for whatever it is that we're trying to store. The linear node itself doesn't really know anything about its elements or properties or methods because it's implemented with generics, so it can't really do anything specific with that element. All it can do is contain a reference to it. And really the node just knows whether it contains the element reference and whether or not it has links to other nodes. So that's it. This is a utility class that we will draw upon to build different data structures that we want to have links between. So using these linear nodes is going to be an alternative to storing all of our elements in something like an array. Okay, thanks for listening.